Alright, so for number one, you have to describe the effect of each transformation on the parent function, graph the parent function f of x and its transformation g of x, then state the domain, range, and y-intercept of each one. So right here I just wrote the reference points for the first one, and because it's a parent function there is no transformation, so these are the points we're going to graph. For g of x, this is the a, right? So the a you multiply by y. It affects the y. So that's what I was going to do next. 1/2 times 2 is 1. Oops, 1. 2 times 1 is 2, and 2 times 2 is 4. So this one's going to have a vertical stretch by a factor of 2, and we're going to graph it right now. So the domain for both of them is all reals. The range for both of them is y greater than 0. So I'll just write it in interval notation. The y-intercept for f of x is 0, 1, and the y-intercept for g of x is 0, 2. Alright, so the same parent function as number 1, 2 to the x. In g of x, you have the a equal -5, so that negative is going to make the function reflect over the x-axis. And the 5 is going to make it stretch vertically by a factor of 5. So the x's stay the same, no change there. The y's we're going to multiply by -5, so this becomes -5/2 or -2.5. This becomes -5, and this becomes -10. So now we're going to graph it. Okay, so here you see the graphs. F of x is in blue, g of x is in orange, and I just plotted the points and connected them. Okay, so now we're going to do domain, which again, for all exponentials, the domain is all reals. The range for f of x is from 0 to infinity, from 0, greater than 0. For g of x, it's the opposite. It's less than 0, because all the points are below the x-axis. So how you write that would be from -infinity to 0. Okay? The y-intercept for f of x is 0, 1, and the x-intercept is 0, -5. So in this case, g of x has an h value of -2, so that means that we are going to take x minus 2. We're going to take these x values and subtract 2. Why? Because h is -2. Remember, you do the opposite. So now we're going to transform the points. So -1 minus 2 is -3, 0 minus 2 is -2, and 1 minus 2 is -1. In this problem, the y's stay the same. So what's happening is this graph, g of x is translated to the left 2 units. And now we're going to graph it. Okay, so here we see the blue and the orange graphs. The blue is the parent function. So g of x is translated 2 units to the left. So now we're going to answer the domain, range, and y-intercept. Again, any exponential function has a domain of all real numbers. The range for both of them is from 0 to infinity. They're both graphed above the x-axis. And the y-intercept for the first one is 0, 1. For the second one, it's not as obvious, and because if you notice here, none of these are the y-intercepts right here. So remember, check your notes. It says replace the x with a 0 and solve for y. So this gives me 2 squared, which is 4. So this would be 4. Alright, so for number 4, g of x has a value, a k value of 5. Okay, so that means that the y is going to be transformed and translated 5 units up. So 5 plus 1/2 is 5.5. Oops, sorry about that. 5.5. 5 plus 1 is 6. 5 plus 2 is 7. So now we're going to graph. Alright, so here are the graphs. The blue one, the parent function, it's where it's always been for the past 3 problems. 4 with this one. The g of x you could see the translation 5 units up. Notice I drew the horizontal asymptote right here. It's like a teal color. It's a light teal. And so I drew it because that way it helps me, it guides me when I'm drawing this part of it, that I won't pass that line. Okay, so now we're going to do the domain, range, and y-intercept. So the domain is always going to be all reals. Okay, I've been writing it with the R, but you could also write it like this. The range for the first one is everything greater than 0. The range for g of x is everything greater than 5. Okay, because that's what the k value is. The y-intercept for the first one is 0, 1. And the y-intercept for g of x is 0, 6. Alright, so for number 11, a is 2, h is negative 2, and k is negative 1. Remember, h is the opposite of what you see, and k is what you see is what you get. So that means that the x is affected by the h, so I'm going to put x minus 2. The y is affected by the a and the k, so it's going to be 2y, because a is 2, minus 1. So now I'm going to transform the points. So negative 1 minus 2 gives you negative 3. 2 times 1/3 is 2/3, minus 1 is negative 1/3. 0 minus 2 is negative 2. 2 times 1 is 2. 2 minus 1 is 1. 1 minus 2 is negative 1. 3 times 2 is 6. 6 minus 1 is 5. So that's what we're going to graph. So the domain is all reals, or you could write it, with interval notation. The horizontal asymptote, remember, depends on k, so it's going to be y equals negative 1 because k is negative 1. So I'm going to go ahead and draw that one in first. I'm going to use this light color because it's only a guide. It's not part of the graph, it's just a guide. Now I'm going to plot the points. Negative 3, negative 1/3. It's about right here. Negative 2, 1. Negative 1, 5. So it's about here. And so it's going to go just something like that. Okay? And the range, oops, I almost forgot the range. Again, it's depends on k, and it's above the k value, negative 1, so you're going to say from negative 1 to infinity. Alright, so number 14, the h value is negative 1. The a is negative 3. So this is the a right here. The h I got from here. So remember, it's the opposite of that sign. So this, because it's x minus h, so that means h is negative 1. And then k is positive 3. And that I got from here. So what this means is that I'm going to take x minus 1 and then negative 3y plus 3. Okay? Because it's ay plus k for the y, the transformations of y. So now I'm going to apply the transformation. So negative 1 minus 1, negative 2. Negative 3 times a half is negative 3 halves, which is negative 1 1/2. So 3 minus 1 1/2 is 1 1/2. Oops. Sorry about that. 1 1/2. 0 minus 1 is negative 1. Negative 3 times 1 is negative 3. Plus 3 is 0. And then 1 minus 1 is 0. Negative 3 times 2 is negative 6. Plus 3 is negative 3. Okay, so now we're going to graph this. So the domain is all reals, so I'll write it like this time. The range, well, we'll do that when we graph it. And then horizontal asymptote is y equals 3 because that's the k value. Okay, so let's plot the points. Negative 2, negative 1/2, negative 1 1/2, so that'd be about here. Negative 1, 0, and 0, negative, 0, negative 3 would be here, and this one would be positive 1 1/2. So negative 2, positive 1 1/2 is right here. Sorry about that. Before I connect the dots though, I'm going to draw the horizontal asymptote at y equals 3, because that's going to help me connect the points. Okay, so now I'm going to connect the points something like this, like that. So the range would be all y less than 3, so you can write it like all y such that y is less than 3, or in interval notation it would be negative infinity to 3. So for number 1, this is on the second page on 13.2. The reference points are negative 1, 1 over b. So notice how 1 over b, because b is 1/2, 1 over b is 2. It's a reciprocal. Okay, so now the k value here is 3. So that means that y's are going to be adding 3 to the y's. Okay, so negative, the x's stay the same. Okay, and then so 2 plus 3 is 5, 1 plus 3 is 4, 3 plus 1/2 is 3.5. And that's what we're going to graph. So there are the 3 dots, the 3 points, and then I just drew the horizontal asymptote on y equals 3. So now I'm going to connect the points. So like that, and it just gets closer and closer to the horizontal asymptote. The domain is all reals, and the range is all y's greater than 3, so I could write it in interval notation like this. So in this problem number 2, again, negative 1 is 1 over b. Since b is 1 over 10, then 1 over b would be 10. 10 over 1. The h is negative 4, so that means that x's are going to be, we're going to subtract 4 from all the x's. So we have negative 1 minus 4, negative 5. And then 0 minus 4 is negative 4. The y's stay the same. 1 minus 4 is negative 3. Okay, and that's it. We're going to graph it. Alright, so there are the 3 dots plus the horizontal asymptote. Because k is 0, because there's nothing right here, right? K is 0, I drew the asymptote at y equals 0. Okay? So now we're going to connect the points. It's a very steep curve because the base is 1/10, and when you take the reciprocal, it's 10. So let me get the right color. And so it goes like this. Almost like an L. So steep. Okay, so the domain, all reals, and the range is all values, all y's greater than 0. Alright, so in this problem, h is positive 1.